Well control situations are one of the worst things that can happen in a drilling environment. Significant potential for loss of life and damage to the environment. So trying to make sure that we reduce that likelihood and reduce the occurrence is of paramount importance to the industry.
Today is a vitally important day for Safe Influx because we're taking our automated well control technology and migrating it from the simulator environment into the real world using a real world rig. We have installed our equipment on this facility and we're going through the process of demonstrating that our technology will function perfectly on a real rig as it has done in the simulated environment.
We looked at taking the human factor element away from well control, and the system itself will actually take control of all the rig once it's identified as an influx, automating the well control sequence and shutting the well in safely. We designed the system to cover all rigs, land rigs and offshore rigs, and our system can be hooked and plugged into cyber rig systems and also the land-based rig systems itself. Our system comprises of a small unit and a human-machine interface touchscreen for the driller to configure and operate, and that sits in front of the driller, and a control system it will actually sit in a nice controlled room near all the drilling equipment controls itself.
Finesse Control Systems, we specialise in development of bespoke solutions for automation, and we've developed PLC, which is Programmable Logic Controller based system, which monitors the instrumentation on the rig and takes the logical decisions about what to do and replaces the decision making that the driller would have to make normally on a manual rig to step through a sequence of operations to bring the rig into a safe condition following the detection of an influx.
Tests so far, we've seen that it's 5 times more efficient than the current manual method, which is the human method, and it reduces the influx size dramatically. On a detection of an influx, it will instantly actually take control of equipment, it will raise the drawworks, it will stop the drawworks at the correct space out height where we can close the BOP in, it will continue to monitor, then it will actually start shutting down the equipment. So the top drive, then the mud pumps, will actually continue to monitor the well, and if it still sees an influx, it will actually then close the BOP in. And it's all done systematically and in a controlled fashion. A human on an influx detection may see a flow change, may have an alarm going off, and then he'll take control of the equipment. So he'll then have to identify that there is an increase in flow, take control of the rig equipment, he'll probably space out and then continue to monitor and then start to shut down the rotary and then the mud pumps and then continue to monitor, and if he continues to see flow then he will actually go and actually close the BOP, which tends not to be near him, it's quite a distance away, normally in the back of the driller's cabin itself, and all that takes time.
It's really important as well, I think, to recognise the way that they've been able to integrate this new type of technology into what you would class as a quite old traditional type of rig system. So I think that bodes well for the existing infrastructure of not only the North Sea but the oil industry in general, as well as its capability to interface seamlessly with new rig systems.
We have nearly 40 additional modules that can also be implemented using the same technology that we have to cover every facet of the well construction and decommissioning operations. We feel if this technology can be applied to every drilling rig, we'll be able to save hundreds of lives around the world.